We continue our discussion here in Chapter 7 on right triangles. We're going to actually transition now into something that you're going to see a lot down the road, especially in Algebra 2 and even a little bit in pre-calc as well. And that is this idea of sine, cosine, and tangent, or what we call trigonometric ratios. Okay, so when we say right triangle trig, this is what we're talking about: sine, cosine, and tangent. So a trigonometric ratio is simply a ratio of the lengths of two sides in a right triangle. In a right triangle, these ratios help to find the measure of either a side or an angle. Okay, and we're going to focus on just the side portion of this for this video. So again, it's simply a ratio. All right, and I'm going to try to explain this a little bit easier. So here's what the ratios are. Okay, you have your sine. Your sine ratio. The sine of an angle, I'm looking underneath definition here. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. And so what you're always going to want to do is first identify what angle you're using. One thing I will tell you, you will never, ever, ever use the right angle when working with right triangle trig. Okay, it'll always be one of the two acute angles. So in the diagram at the right here, let's just say first we choose to work with angle A. Well, with respect to angle A, the side that is opposite of angle A is little a. The hypotenuse is clearly C. And then the other side that we're going to talk a lot about is what we call the adjacent side. And we're going to use A for that. So the adjacent side is the side essentially that's next to the angle. That's not the hypotenuse, and that's the easiest way, I think, for students to identify the adjacent side. So relative to angle A, if I'm looking at the sine of A now, okay, the opposite side of A is little a. Well, let me just say this. It's opposite over hypotenuse. The opposite side in the diagram here is A, and the hypotenuse is little c. And so the sine of A would be A over little c. Now if I shift gears here and I say, well, wait a second, that's not how I wanted to look at the diagram. I wanted to look at the diagram with respect to angle B. Well, now the opposite side to angle B is this guy, the hypotenuse is this, and the adjacent side would be that. And so if we're concerned with sine of B, still it's opposite over hypotenuse, but now the opposite side is B, the hypotenuse is still C. All right, and so that's what we're looking at as we go through and use this right triangle trig stuff. Okay, it's always identify your opposite, your adjacent, your hypotenuse. So the cosine is the adjacent over the hypotenuse. Okay, so for cosine we're looking adjacent over hypotenuse. I'm just going to fill it in for both of these. And again, it all depends on what angle you're looking at. If I look at angle A, with respect to angle A, obviously this is the hypotenuse no matter what. The adjacent side there would be the B. So you'd have B over C. And then if I'm looking more with respect to angle B, well, now your adjacent side is here. And so it would be A over C. It's all about perspective. And you'll notice as we go through our notes that one person might use one angle, which would force you to use a certain trig ratio. Someone else might use another that would force a different trig ratio. But in the end, you end up with the same result anyway. And then finally, the tangent ratio is opposite over adjacent. Opposite over adjacent. And again, it all depends on what angle we're looking at. With respect to angle A, this would be opposite, that would be adjacent. So you would do A over B. And then if I'm looking with respect to angle B, this would now be your opposite, this would be your adjacent, so you'd have B over A. Again, I think that once we start looking at examples that involve numbers, it'll make more sense. So here's the acronym that's going to help you remember all of this stuff. So we just took a few minutes to go through that portion of the notes so that you understand how to identify opposite, adjacent, and hypotenuse. But really, at the end of the day, this is really what you want to remember here. SOHCAHTOA. Okay, the S here stands for sine, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And that's going to be the easiest way for you to remember all of these trig ratios. Okay, so in example number 1, it says write each answer as a fraction and as a decimal rounded to 4 places. I'm going to do the fraction. You can do the decimal on your own, plug it in, and just, that's all you're doing. Okay, so the sine of angle U. Let's do everything with respect to angle U. If I'm looking at angle U, the hypotenuse is clearly this guy. The side opposite of angle U is over here, the 16. It's across from it. And then 30 is the only other piece left, so it's the adjacent side. So the sine, remember, so, S-O-H, and again, I'm just going to, I scrolled down a little bit far, but I'm just going to sketch this down here, write down the acronym. So sine is opposite over hypotenuse. Well, the opposite is 16. The hypotenuse is 30. I'm going to reduce that down. Okay, 2 goes into 16, 8. 2 goes into 30, 15, not 30. There's the sine of U. The cosine of U. Remember, ca, AH, adjacent over hypotenuse. That would be 30 over 34. 2 goes into both of those, 15 over 17. And then finally, the tangent of U, TOA, opposite over adjacent. That's 16 over 30. 2 goes into 16 8 times. 2 goes into 30 15 times. Now I'm backtracking here because I realize now that I made a dumb mistake here. For the sine of U, I said it was opposite over hypotenuse, but that's not what I did because the hypotenuse is 34, not 30. That wasn't too right. Now 2 goes into both of those. 2 goes into 16 8. 2 goes into 34 17. So there's your 3 ratios. Okay. There are your 3 ratios. And then you could do the same thing for W. I think you have a good handle on it, so I'm going to let you create the trig ratios for sine, cosine, and tangent of W. Okay, example 2 says use your knowledge of special right triangles to write the trig ratios for 45, 45, 90. So again, the sine of 45 is opposite over hypotenuse. Well, if this is S, then this is S square root 2. We know that from section 4. Okay? And so the sine is going to be S over S square root 2. Well, your S's are going to cancel, so you're left with 1 over root 2. We know we can't have that, so we rationalize. And so you end up with the square root of 2 over 2. So in any 45, 45, 90, if you look at the sine ratio, the opposite over the hypotenuse, it will always reduce down to square root 2 over 2, no matter what. Okay? So now for the cosine, that's adjacent over hypotenuse. Well, again, that's just going to be S over S root 2. And we notice that this is actually the same thing that we just did. So root 2 over 2 is going to be the sine, or I'm sorry, the cosine ratio as well. And then finally, the tangent ratio is opposite over adjacent. So if I'm looking at this angle, the opposite side is S. The adjacent side is also S. That's just 1. So if you have a calculator and you plug in tan 45 and hit enter, it's going to tell you 1. As long as your calculator is in degree mode. We'll talk more about that in class. Okay. Example 3, use special right triangles to find the exact values. In other words, leave the square root in there or leave the radical in there. I'm going to let you guys plug through that. Okay, you guys should be able to do that now. It's very similar to what we just did. Set them up, rationalize if needed. Okay, it says write each answer as a decimal rounded to the nearest 4 places. So all you're going to do is grab a calculator. Every calculator is a little bit different. Excuse me. If you have a graphing calculator, then the sine, cosine, tangent buttons are right on the front of it. Some of your scientific calculators, you actually have to go and search for them a little bit. So we could talk more about that tomorrow. I'll help you out with your specific calculator and help you find where everything's at. So sine of 62, literally just plug in sine of 62. Hit enter. Sine 62, there we go. Okay, so 0.8829. Now, if you're looking at that and you're saying, wait, that's not what I got a negative number, okay? Or I got something way different, chances are you're not in degree mode on your calculator. So you're going to have to kind of mess with your calculator and find the settings to change it to degree mode. If you're not sure about how to do that, again, we can answer those questions in class, but it's important that you know how to use your own specific calculator. Okay, so the next one is cosine 45. That's just 0.7071. Remember on the previous slide, or actually 2 slides ago, we said that the cosine of 45 was root 2 over 2. So I bet you if you plug in square root 2 divided by 2, you're going to get the same decimal. Okay. The tangent of 30 is 0.5774. And then finally, the tangent of 45, if I remember right from a few slides ago, should just be 1. So those are pretty basic ideas there. Plug in and go. Okay. It says find each length rounded to the nearest hundredth. So this is really where we're going to make our money. This is where we're going to be concerned at. So part A, we're trying to solve for BC. Call it X. Okay, you'll notice in big bold letters there, make sure your calculator's in degree mode. I'll remind you of that consistently throughout this chapter. So again, the angle that we're going to work with, they already give us 15, so why do any more work? If you wanted to use the triangle sum theorem, you could do that, and you could say, okay, so I know they got to add up to 180, so this angle here has got to be 75, and then you can use that angle, but again, you're just adding more work for yourself. So the way you're going to set this up is you're going to say, okay, here's the angle I'm working with, and then you ask yourself, what information do I know, and what do I want to know? So the thing that you know is this side here, and relative to our 15-degree angle, that is the opposite side. This is obviously your hypotenuse, and this is your adjacent. So you know the opposite, you want to know the adjacent. So you're going back to SOHCAHTOA. TOA. Which one has O and A in it? Because those are the 2 I want, and it's TOA, T-O-A. And so that's what you're going to use. You're going to use tangent. So you say tangent of your angle equals, the opposite side is 10.2. The adjacent side, call it X. And then I find that with most students it's easiest just to put this guy over 1 and then cross multiply, so you end up with X times tangent 15 degrees equals 10.2. And then you divide both sides. You got to get X by itself, so you divide both sides by the tangent of 15 degrees. Okay, so the exact answer would be X equals 10.2 divided by the tangent of 15 degrees. If it said round to the nearest hundredth, so I can go ahead and plug that in. By the way, leave the trig ratio in there until the very end. So in other words, don't plug in for tan 15 right here and put a decimal, because that'll the earlier you plug that in and get a decimal, the further away from the exact answer your approximation is going to be. So 10.2 divided by tangent of 15 equals 38.07. 38.07 feet. Make sure you put units on there. Okay, so it's just kind of that's a quick introduction to how we're going to use these trig ratios. So in part B, same idea. I'm solving for QR, call it X. I know this angle, so I would label every side relative to that angle. This side is opposite. This is your hypotenuse, which leaves this guy to be your adjacent. Okay, so the 2 pieces of information I'm going to use are opposite and hypotenuse. SOHCAHTOA. OH is sine. So sine of 63 degrees equals opposite over hypotenuse. Okay, again, put this over 1, cross multiply. X equals 12.9 times sine 63 degrees. That would be our exact answer, but again, it says to round to the nearest hundredth, so 12.9 times sine 63, and that leaves us with roughly 11.49 centimeters. Okay. Part C, solve for FD. Again, at this point I would probably pause the video and kind of see where you're at on your own. So here's my angle. I want this. Okay, so relative to the angle, this is opposite, adjacent, and the hypotenuse. So I'm using O and H again. I'm sorry, I'm not using O and H. I'm using A and H. Okay, because I know the A, I want to know the H. So you say that's cosine, right? Because it's ca, adjacent, hypotenuse. Cosine 39 degrees equals 20 over X. Put this guy over 1, cross multiply. X times cosine 39 degrees equals 20. Divide both sides. I got to get X by itself, so I got to divide by cosine 39 degrees. Okay, so your exact answer would be this, but again, we want an approximation, so we're going to do 20 divided by cosine 39 degrees equals 25.74. and our units are meters. Okay. So again, go ahead, take a look at part D down there on your own. Identify what angle you're going to use, what information you want to know, what information you do know, and then use that to set up a trig equation. So here you go, part E. Again, try it on your own. Okay. Example 6 we'll do together here. It says the glide slope is the path that a plane uses while it is landing on a runway. The glide slope usually makes a 3-degree angle with the ground. A plane is on the glide slope and is 1 mile from touchdown. They want to know what is the plane's altitude. So, perspective. All right. There's your plane. I'm not a very good drawer, so there's your little stick figure plane. Okay, it's actually descending, so I probably should draw it on an angle going downward, but it's descending. Okay, and let's just call this guy here the runway. We know that when it's on that glide slope, it makes a 3-degree angle with the ground. Okay, so it's a 3-degree angle with the ground. We know it is 1 mile from touchdown. Okay, it is 5,280 feet from touchdown. So what we'll do, let's use the feet. Okay, and so when I read this, I'm thinking that the plane itself is 1 mile from touchdown. So that means I'm going to call this side 5,280 feet. Okay, we're talking about the distance from the plane to where it's going to hit the runway. Okay, and the question really is, what is the height? And so you'll notice, once you have the diagram drawn, it's pretty simple. Here's my angle. I want to know this side, which is the, I was going to say opposite, but I wrote down H. Doesn't make a lot of sense. That's the opposite side. Clearly, this is the hypotenuse. Opposite hypotenuse tells you to use sine. So the sine of 3 degrees equals opposite over, and then hypotenuse is 5,280. Again, put this guy over 1, cross multiply, x equals 5,280 times the sine of 3. And so the altitude is roughly 5,280 times the sine of 3, 276.33 feet. Whoops. There we go. Okay. So the plane is still 276 feet off the ground. In example 7, they're fortunate enough they draw a diagram for you. It says you walk from one corner of a basketball court to the opposite corner. Write and solve a proportion using a trigonometric ratio to approximate the distance of the walk. All right, so again, they've done you a favor here, and I'm going to actually let you guys work through this one. Here's your angle. You know that side. You want to know this side. Solve for x. You guys should be able to do that by now. Example 8, same idea. It's a story problem. Some of them will give you a diagram, others will not. In my opinion, when we don't give you the diagram, that's when it poses the most difficulty, obviously, because you have to come up with a diagram on your own. So don't get used to getting that diagram, but if we give it to you, makes your life even easier. Okay. Example 9, again, same idea. Now you're going to solve for x and y. All right, so just pick one first and solve for it. So if that's 35, okay, we'll do this one together just to kind of wrap things up here. So if that's 35 and I want to find x, that's the opposite, that's the adjacent, that's the hypotenuse. Okay, so if you want to set up 2 separate equations right now to solve for x and y, you can. So if I want to solve for x first, that's opposite hypotenuse, that's sine 35 equals opposite over hypotenuse. Cross multiply, x equals, and I'm going to go ahead and actually just plug this directly into my calculator for save a little bit of time here in the video. So 20 times sine 35 equals 11.47 feet. Okay, so x is 11.47. Now, what I don't want you to do is I don't want you then to say, okay, so this is 11.47. Now I'm going to use tangent. I have opposite. I want to know the adjacent. Never use an approximation that you came up with in the problem if you can help it. For example, in this problem, you can help it, right? Because if you want to know what y is, Well, relative to 35, y is the adjacent. You know that the hypotenuse is exactly 20. So those are the two lengths that you're going to want, or those are the two pieces you're going to want to use. So the way you'll set up for y is you're going to say cosine 35 equals y over 20. And again, put this over 1, cross multiply, y equals 20 times cosine 35, and that's 16.38 feet. All right. So again, I hope that this video at least provided you with a decent understanding of trigonometric ratios and a brief introduction as to how to set up different problems in working with them. So understand the advantage to knowing these trig ratios is that now it doesn't have to be a special right triangle, and we don't have to know two side lengths. We can know an angle on one side, and we can still solve for all of the sides in the diagram. As always, if there are any questions or concerns regarding anything that was mentioned in this video, bring them to class and we'll be sure to address those first thing.